Bataan Peninsula, Philippines, April 9, 1942. When Japanese ordnance engineers finally silenced the last American machine gun nest and approached the captured weapon, they found something that defied everything they understood about automatic firearms. The barrel was still too hot to touch after firing nearly 40,000 rounds over 3 days of continuous combat. The weapon showed no signs of catastrophic failure. In Tokyo's military laboratories, this impossibility would soon shatter Japanese confidence in their own weapons development and rewrite their understanding of American industrial capability. One man's obsessive pursuit of perfection had created a machine that refused to die. The story begins not on a battlefield, but in a cramped workshop in Ogden, Utah, where a self-taught gunsmith named John Moses Browning sat hunched over a workbench scattered with springs, pins, and barrel fragments. The year was 1918, and the First World War was grinding toward its bloody conclusion in European trenches. Browning, already legendary for designing the M1911 pistol and the Browning automatic rifle, faced a problem that had stymied military engineers for decades: how to create a heavy machine gun that could sustain fire indefinitely without melting, jamming, or exploding. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The existing solutions were inadequate. Water-cooled machine guns like the Maxim required cumbersome cooling systems that weighed nearly 100 pounds when filled. Air-cooled designs overheated rapidly, their barrels warping after a few hundred rounds of sustained fire. The military wanted something impossible, a weapon that combined the sustained firepower of water-cooled guns with the portability of air-cooled designs, capable of firing from ground mounts, vehicles, and aircraft without modification. Browning's approach was characteristically methodical. He studied every machine gun failure report he could obtain from the War Department. He calculated heat dissipation rates. He experimented with different barrel thicknesses, chamber dimensions, and recoil mechanisms. His workshop became a laboratory where theoretical mathematics met practical metallurgy, where each failed prototype taught lessons that informed the next iteration. The breakthrough came from an unexpected direction. Browning realized that the problem was not just about cooling the barrel, but about distributing thermal stress across the entire system. He designed a short recoil operation where the barrel and bolt moved together for a brief moment during firing, then separated as the bolt continued rearward to extract and eject the spent cartridge. This system absorbed and distributed recoil energy more efficiently than any previous design. But the true innovation was in the barrel itself. Browning created a thick-walled, chrome-lined barrel with carefully calculated dimensions that allowed it to absorb and dissipate heat without warping. The barrel could be changed rapidly in combat, a procedure that would take a trained gunner less than 6 seconds. This quick-change capability meant the weapon could fire indefinitely, limited only by ammunition supply and barrel availability. On the 15th of October, 1918, John Browning demonstrated his prototype, 50 caliber machine gun, at the War Department testing range near Washington, D.C. The assembled military observers watched as the weapon fired 20,000 rounds in a single session without malfunction. The test officer, Colonel William Crozier, recorded in his official report, "This weapon represents a quantum advancement in automatic weapons technology. Its sustained fire capability exceeds anything currently in service with any military force worldwide." But World War I ended before the weapon could reach production. In the chaos of demobilization and military budget cuts, Browning's revolutionary design languished in bureaucratic limbo for over a decade. It was not until 1933 that the U.S. military officially adopted the weapon as the Browning machine gun, Cal 50 M2. The timing proved providential. As war clouds gathered over Asia and Europe in the late 1932, American factories began producing the M2 in increasing numbers. The weapon's specifications were remarkable for the era. It fired the 50 caliber BMG, Browning machine gun cartridge, at approximately 450 to 550 rounds per minute, with an effective range exceeding 1,800 meters against ground targets and 1,000 meters against aircraft. The weapon weighed 84 pounds unloaded, far lighter than comparable heavy machine guns of other nations. What separated the M2 from every other machine gun in existence was not just its specifications, but its reliability. Browning had designed every component with redundancy and durability in mind. The weapon could function in Arctic cold and tropical heat. It could be buried in sand, submerged in water, or caked with mud, then restored to operation with minimal cleaning. Most remarkably, testing showed that with proper barrel changes, the weapon could fire over 1 million rounds before critical components required replacement. This million-round capability was so far beyond contemporary weapons technology that when American engineers first reported it, their superiors suspected calculation errors. The Soviet DShK heavy machine gun, considered excellent by European standards, required major parts replacement after approximately 80,000 rounds. The German MG-34, praised for its engineering sophistication, needed rebuilding after 150,000 rounds. The Japanese Type 92 heavy machine gun, despite its rugged construction, suffered critical failures around 50,000 rounds. The M2's longevity was no accident. John Browning had died in 1926, but his design philosophy lived on in every component. The receiver was milled from a single block of high-grade steel. The bolt was heat-treated to exceptional hardness. The feed mechanism used a simple but ingenious system that reduced the number of moving parts and thus the number of potential failure points. Even the ammunition itself was designed to work seamlessly with the weapon. The 50 BMG cartridge used a carefully formulated powder that burned cleanly, reducing fouling and extending barrel life. By December 1941, when Japanese forces swept across the Pacific, American military units had deployed thousands of M2 machine guns throughout their defenses in the Philippines, Guam, Wake Island, and Pearl Harbor. Most American soldiers had limited training with the weapon. Few understood its capabilities. Fewer still appreciated that they were operating the most reliable automatic weapon ever created. The Japanese military, confident after their stunning victories in China and Southeast Asia, viewed American equipment with contempt. Japanese intelligence reports from the 1,930 seconds had characterized American weapons as adequate but unexceptional. Japanese machine guns like the Type 92 were considered superior due to their use of the 7.7 mm cartridge, which Japanese doctrine favored for its combination of range and controllability. This assumption would prove catastrophically wrong. Staff Sergeant Michael Donovan pressed his back against the sandbagged wall of the machine gun position and tried to control his breathing. The sound of Japanese artillery had been constant for 6 hours, the shells systematically destroying the American defensive lines across the Bataan Peninsula. Through gaps in the sandbag wall, Donovan could see pillars of black smoke rising from positions that had been manned by his friends just hours earlier. It was the 7th of April 1942. The siege of Bataan was entering its final, desperate phase. For 3 months, American and Filipino forces had held against overwhelming Japanese numbers, but starvation, disease, and ammunition shortages were taking their toll. Donovan's machine gun company had started the defense with 120 men. Malaria, dysentery, and Japanese attacks had reduced that number to 37. The M2 Browning mounted on its tripod in front of Donovan had been in continuous use since January. The weapon's serial number 127856 was etched into Donovan's memory. He had cleaned it obsessively, changed barrels according to the manual specifications, and maintained it with the reverence other men reserved for religious icons. In the chaos of the siege, with food running short and medical supplies exhausted, the M2 had never failed him. Private First Class James Chen, Donovan's assistant gunner, crouched beside the ammunition cans stacked against the rear wall of their position. Chen, a Chinese-American from San Francisco's Chinatown, had joined the army in 1940 seeking adventure. He found only terror and exhaustion in the Philippine jungle. "Sergeant, We've got maybe 4,000 rounds left, Chen said, his voice tight with stress. After that, we're down to rifles. Donovan nodded but said nothing. 4,000 rounds seemed like a lot until you considered that the M2 could expend that amount in less than 10 minutes of sustained fire. And the Japanese were coming not in small probes, but in a massive assault designed to break through the American lines once and for all. The distinctive sound of Japanese machine gun fire echoed from the north, the slower rate of fire of the Type 92 easily distinguishable from the M2's faster rhythm. Donovan had learned to identify weapons by sound, a survival skill developed over months of combat. The Japanese were closing on positions held by Easy Company, about 800 yards to their left. "They'll hit us next," Donovan said quietly. "When they come, they'll come in force. We need to make every round count, but we also need to break their assault before they can close with us. If they get into grenade range, we're finished." Chen understood. The Japanese infantry tactics emphasized aggressive close-quarter combat, where American firepower advantages were negated. The M2's role was to stop those charges at distances where Japanese grenades and bayonets were useless. At 1,437 hours, the Japanese artillery barrage shifted southward, away from Donovan's position. The sudden silence was more unnerving than the shelling. In that eerie quiet, Donovan heard new sounds, officers shouting commands in Japanese, the metallic clicks of rifle bolts being worked, the rustling of hundreds of men moving through the jungle undergrowth. "Here they come," Donovan whispered. "Chen, feed the belt smooth, no jerks. If this weapon jams, we die." The first wave of Japanese infantry emerged from the tree line 400 yards distant. They advanced in loose formation, rifles at port arms, moving with the confidence of soldiers who had conquered half of Asia. There were at least 200 of them in the initial assault, with more visible behind. Donovan aimed carefully, his thumbs, resting on the spade grip's butterfly trigger. The M2's rear sight was aligned on the center of the advancing formation. He let them close to 300 yards, close enough that missing was nearly impossible, far enough that their return fire would be less accurate. "Firing," Donovan called, and pressed the trigger. The M2 roared to life with its distinctive heavy pounding rhythm. The 50 caliber rounds, each one nearly 4 inches long and weighing 2 ounces, tore through the jungle foliage and into the Japanese formation. The effects were catastrophic. Where the 7.7 mm bullets from Japanese rifles might wound or disable, the 50 caliber rounds destroyed. They shattered trees, penetrated rocks, and inflicted horrific trauma on human bodies. The Japanese formation wavered, then broke as soldiers sought cover. But Donovan kept firing, traversing the gun methodically from left to right across the tree line, then back from right to left. Chen fed the ammunition belt smoothly, his hands steady, despite the terror, calling out round counts as each 100-round belt fed into the weapon. 100 gone, 200, 300. The barrel began to glow faintly, heat shimmer visible above the chamber. Donovan felt the weapon's vibration through his hands, the recoil forces absorbed by the tripod and transmitted through the ground. His world narrowed to the rear sight, the target area, and the rhythm of fire. Everything else, the sounds of battle from other positions, the smell of cordite and burned gun oil, the fear twisting his stomach faded into background noise. The Japanese tried to advance again, officers waving swords and screaming orders. Donovan cut them down with short, precise bursts. The M2's tracer rounds every 5th round in the belt painted red lines through the air, marking his fire and allowing him to adjust aim without raising his head fully above the sandbags. At 600 rounds, Chen called out, "Barrel change." Donovan released the trigger, immediately. The barrel change procedure had been drilled into both men until they could perform it blindfolded. Chen lifted the barrel handle while Donovan pulled the carrying handle up and rotated it to the right, releasing the barrel lock. The hot barrel slid out of the receiver, its surface radiating waves of heat. Chen set it aside carefully. The barrel was hot enough to ignite the surrounding grass and inserted the spare barrel, cool and ready. Lock engaged, carry handle down, and they were ready to resume firing. Elapsed time, 5 seconds. The Japanese used those 5 seconds to advance another 50 yards. Donovan resumed firing, his tracer rounds finding targets among the trees and fallen logs where Japanese soldiers sought cover. The psychological effect of the 50 caliber machine gun on enemy infantry was something no training manual could fully convey. The sound alone, deeper and more threatening than any rifle or light machine gun, created fear. The visible effects, as rounds splintered trees and shredded cover, amplified that fear into terror. But Japanese officers drove their men forward with fanatical determination. A second wave emerged from the tree line, moving to flank Donovan's position from the right. Chen spotted them first. Right flank, 200 yards, moving to flank. Donovan traversed the gun right, bringing the new threat into his field of fire. The M2's mount allowed rapid traversal and elevation changes, and he used that capability now, engaging targets across a 90-degree arc. The flanking force took heavy casualties but continued advancing, using fire and movement tactics that showed these were experienced soldiers, not conscripts. The engagement settled into a brutal rhythm. Donovan firing, Chen feeding ammunition and calling barrel changes. The M2 hammering away at waves of Japanese infantry who kept coming despite horrific casualties. The weapon's reliability was absolute. Despite sustained fire that would have destroyed lesser machine guns, the M2 functioned flawlessly. Spent brass casings piled up around the position, creating an ankle-deep carpet of gleaming metal. At 3,000 rounds expended, with only 1,000 rounds remaining, the Japanese assault finally broke. The survivors retreated to the tree line, leaving their dead and wounded scattered across the killing ground. Donovan ceased fire, his hands cramping from gripping the spade grips for nearly 40 minutes of sustained combat. The silence that followed was broken only by the sounds of wounded men crying out in Japanese and English from various positions across the battlefield. Donovan's ears rang from the sustained exposure to the M2's muzzle blast. Chen sat slumped against the sandbag wall, exhausted, his hands black with gun oil and carbon residue. "How many do you think we got?" Chen asked quietly. Donovan shook his head. "Don't know. Don't want to know." He ran his hands over the M2, checking for damage or loose components. The weapon was hot, filthy with carbon buildup, but undamaged. Serial number 127856 had fired over 3,000 rounds in less than an hour without a single malfunction. The respite was brief. At 1,630 hours, the Japanese artillery resumed, and Donovan knew the next assault would come soon. Easy Company's position to their left had gone silent, whether because they had been overrun or had simply expended all their ammunition, Donovan could not tell. When darkness fell, Captain Robert Hayes, the company commander, crawled into Donovan's position. Hayes looked like he had aged 10 years in the past 3 months. His uniform hung loose on a frame thinned by starvation rations. His eyes carried the 1,000-yard stare of a man who had seen too much death. "Sergeant, we're finished," Hayes said bluntly. "General King is surrendering the entire Bataan force tomorrow morning. We don't have food, we don't have medical supplies, and we don't have ammunition to sustain another assault like today's. It's over." Donovan felt the words hit him like a physical blow. Surrender. After months of fighting, after watching friends die, after holding positions against impossible odds, they were surrendering. "What about the weapons, sir?" Donovan asked, gesturing to the M2. "Do we destroy them?" Hayes shook his head. "No orders yet, but I imagine the brass will want them disabled. Can't let the Japanese capture working American weapons." He paused, looking at the M2 with something approaching respect. "That gun saved a lot of lives today, Sergeant. The Japanese paid in blood for every yard they advanced. You did good work." After Hayes left, Donovan and Chen sat in their position through the night, taking turns keeping watch. Neither man slept. The thought of surrender was harder to process than the combat they had endured. At dawn on the 9th of April 1942, The firing along the American lines gradually ceased as word of the surrender spread. White flags appeared on positions that had been defended with such desperation just hours earlier. Donovan looked at the M2 one final time before the Japanese arrived to take possession. The weapon had fired approximately 40,000 rounds during the siege of Bataan, a number Donovan had carefully tracked in a small notebook, recording each barrel change and ammunition count. The barrel currently installed was the 11th they had used. Despite the intensive use, the weapon showed no signs of critical failure. Given proper cleaning and maintenance, serial number 127856 could have fired another 40,000 rounds without hesitation. Within hours, Japanese soldiers entered the American positions, rounding up the defenders and confiscating weapons. When a Japanese lieutenant examined Donovan's M2, he called over several soldiers to help carry it away. The lieutenant ran his hands over the weapon's surface, noting the carbon buildup and the stacks of spent brass that surrounded the position. He said something in Japanese to his men, and Donovan caught two words. He recognized American and machine gun. The lieutenant looked at Donovan with an expression that might have been respect, or possibly fear. Then Japanese soldiers dragged the M2 away, along with the remaining ammunition and spare barrels. Donovan watched them go, feeling like he was watching a friend being taken prisoner. What Donovan could not know, what no American soldier could have predicted, was that this captured M2 would soon become the focus of intense study by Japanese ordnance engineers. The weapon that had helped hold Bataan for 3 months was about to reveal secrets that would fundamentally challenge Japanese assumptions about American weapons technology and industrial capability. The real story of the M2 Browning was just beginning, and it would unfold not on battlefields, but in Japanese research laboratories where engineers would discover something that seemed impossible, an American weapon that simply refused to fail, no matter how much abuse it endured. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The Imperial Japanese Army Technical Research Institute occupied a sprawling complex in the Kita ward of Tokyo, its grey concrete buildings surrounded by high walls and guard towers. In May 1942, a convoy of trucks arrived, carrying war materiel captured from American forces in the Philippines. Among the crates of rifles, ammunition, and equipment was something that had already generated intense interest among Japan's military leadership. 3 M2 Browning machine guns, along with several thousand rounds of 50 caliber BMG ammunition and a dozen spare barrels. Captain Hideaki Yamamoto, the Institute's chief weapons analyst, stood in the receiving warehouse as workers unpacked the American machine guns. Yamamoto was 38 years old, a graduate of Tokyo Imperial University's engineering program and a veteran of weapons development projects, stretching back to the 1932. He had examined captured Chinese, British, and Russian weapons, always finding them inferior to Japanese designs in critical aspects. He expected the American machine guns would prove similarly disappointing. The first M2 removed from its crate was serial number 127856, the weapon that Staff Sergeant Michael Donovan had used to such devastating effect during the siege of Bataan. The weapon was filthy with carbon buildup and gun oil, its barrel showing the copper-colored heat discoloration that indicated intensive use. Yamamoto ordered his technicians to clean it thoroughly before disassembly and analysis. Over the next 3 days, Yamamoto's team stripped the M2 down to its individual components, carefully measuring, weighing, and photographing each part. The receiver was milled from a single block of steel, its interior surfaces machined to tolerances that impressed even Yamamoto's experienced technicians. The bolt was heat-treated to a hardness that exceeded anything in Japanese machine gun designs. The barrel's chrome lining was immaculate, despite obvious heavy use. The Americans have good machinists, Yamamoto noted in his initial report. The quality of manufacture exceeds our preliminary expectations. However, The weapon's weight and complexity suggest it would be difficult to produce in quantity. Japanese industry could likely not replicate this design without significant retooling. But it was the weapon's operational characteristics that would soon challenge all of Yamamoto's assumptions. On the 18th of May 1942, Yamamoto's team conducted their first live-fire test at the Institute's proving ground outside Tokyo. They mounted serial number 127856 on a test stand, loaded a belt of captured American ammunition, and began firing in controlled bursts to establish baseline performance data. The initial results were unremarkable. The weapon cycled smoothly at approximately 485 rounds per minute. The recoil was manageable. The accuracy at 500 meters was acceptable but not exceptional. Yamamoto made notes on a clipboard, his expression neutral. The M2 appeared to be a competent heavy machine gun, but nothing revolutionary. Then Yamamoto ordered sustained fire testing to determine the weapon's durability limits. This was standard procedure for evaluating captured weapons. Fire them until they failed, then analyze the failure modes to understand weaknesses that could be exploited in combat. Japanese doctrine assumed that sustained fire would reveal critical flaws, as it did in virtually every machine gun design. The M2 fired its first 1,000 rounds without incident. Yamamoto ordered his technicians to continue. At 2,000 rounds, the barrel showed the expected heat discoloration, but the weapon continued functioning. At 3,000 rounds, Yamamoto ordered a barrel change, following the procedure outlined in a captured American manual that had been translated by the Institute's language specialists. The barrel change took less than 10 seconds, and firing resumed. At 5,000 rounds total, Yamamoto began to feel the first stirrings of unease. The Type 92 heavy machine gun, Japan's premier heavy machine gun, typically required significant maintenance after 3,000 rounds and showed signs of parts wear that necessitated component replacement around 5,000 rounds. The M2 showed no such degradation. "Continue firing," Yamamoto ordered. "I want to see where this weapon breaks." His technicians exchanged glances but complied. The M2 continued its methodical destruction of targets downrange, the sound of its firing echoing across the proving ground. At 10,000 rounds, Yamamoto ordered another barrel change and a detailed inspection of all components. The bolt showed minor wear on its locking surfaces, normal and expected. The receiver showed no cracks or stress fractures. The feed mechanism operated smoothly. At 15,000 rounds, Yamamoto called a halt for the day. His team disassembled the M2 completely, examining every component under magnification for signs of imminent failure. They found wear, certainly, but nothing approaching critical failure thresholds. The weapon could clearly continue operating. That evening, Yamamoto sat in his office reviewing his notes. The implications were troubling. If the M2 could sustain 15,000 rounds without failure, it represented a quantum leap beyond Japanese machine gun technology. But perhaps this was an exceptional example, a weapon that had received superior maintenance or had been manufactured to unusually high standards. The next morning, Yamamoto ordered testing of the second captured M2. This weapon showed similar results: sustained fire capability that far exceeded Japanese weapons, no critical failures even after extended firing. The third M2, when tested, performed identically. Yamamoto drafted a preliminary report to his superiors, carefully choosing his words. The captured American M2 heavy machine gun demonstrates sustained fire capability, significantly exceeding our current weapons. Further testing is required to determine the full extent of this capability and the engineering principles that enable it. What followed was the most comprehensive weapons analysis ever conducted by the Imperial Japanese Army. Technical Research Institute. Over the next 6 months, Yamamoto's team subjected the captured M2S to every test they could devise. They fired them in freezing conditions and in tropical heat. They buried them in sand, submerged them in water, and caked them with mud, then attempted to fire them with minimal cleaning. They tested them with captured American ammunition and with Japanese-manufactured copies of the 50 BMG cartridge. The results were consistent and, to Japanese engineers, deeply troubling. The M2 functioned reliably under conditions that would disable Japanese weapons. It maintained accuracy across temperature extremes. It could be disassembled and reassembled with minimal tools. Most remarkably, the weapon showed no signs of imminent critical failure even after 50,000 rounds of test firing. Lieutenant Colonel Takeshi Nakamura, Yamamoto's superior officer, reviewed the test data with growing alarm. Nakamura was a political officer as much as an engineer, responsible for ensuring that weapons development aligned with the Army's doctrinal preferences and budgetary constraints. The M2's performance suggested that Japanese heavy machine gun development had taken fundamental wrong turns. Your report claims this American weapon can fire over 1 million rounds before requiring major component replacement, Nakamura said, his voice tight with skepticism. This seems physically impossible. Steel cannot withstand such stress without catastrophic failure. Yamamoto had anticipated this reaction. He had prepared a detailed technical analysis explaining the engineering principles that enabled the M2's extraordinary durability. The chrome-lined barrel that resisted heat erosion, the heat-treated bolt that maintained dimensional stability under stress, the recoil system that distributed forces across the entire receiver rather than concentrating them at stress points. The Americans have solved problems we did not realize existed, Yamamoto explained. Our heavy machine guns are designed to Japanese doctrine, which emphasizes suppressive fire in support of infantry assaults. We did not design for the sustained fire mission that American doctrine apparently requires. The M2 represents a different philosophy. It is built to fire continuously for extended periods, limited only by ammunition supply and barrel changes. Nakamura studied the technical drawings spread across his desk. The M2's design was elegant in its simplicity, with fewer moving parts than the Type 92 but greater reliability. Every component served multiple functions. The weapon was designed for field maintenance by soldiers with minimal training, not for depot-level repairs by skilled armorers. What are the implications for our own weapons development? Nakamura asked quietly. Yamamoto chose his words carefully. If we assume the M2 represents typical American weapons philosophy, we must conclude that American industrial capacity and engineering sophistication exceed our previous estimates. The precision manufacturing required to produce this weapon in quantity suggests production capabilities we cannot currently match. The metallurgical sophistication, evident in the barrel and bolt construction, indicates materials science research beyond our current knowledge. The silence that followed was heavy with implications neither man wanted to articulate. Japanese military strategy in the Pacific War assumed American weapons would be inferior to Japanese designs, just as American soldiers were assumed to be inferior to Japanese soldiers. The M2 challenged that assumption at a fundamental level. Over the following weeks, Yamamoto's team conducted additional tests, focusing on the .50 caliber BMG cartridge itself. The ammunition was a revelation. The brass cases were manufactured to tolerances that ensured consistent chamber pressure and uniform ballistics. The powder formulation burned cleanly, minimizing fouling. The bullet design optimized penetration and destructive effects. Even the primers showed sophisticated chemistry that ensured reliable ignition across temperature extremes. Yamamoto ordered his team to attempt manufacturing copies of the .50 BMG cartridge using Japanese materials and techniques. The results were humbling. Japanese manufactured copies showed inconsistent chamber pressures, variable accuracy, and increased fouling. The precision required to match American ammunition standards exceeded Japanese industrial capabilities without significant investment in new machinery and quality control processes. In September 1942, Yamamoto completed his comprehensive analysis report. The document ran to 247 pages, including detailed technical drawings, metallurgical analyses, and performance comparisons with Japanese weapons. The conclusions were stark and, for Japanese military leadership, deeply unwelcome. The M2 Browning represents the most advanced heavy machine gun currently in military service worldwide, Yamamoto wrote in his summary. Its sustained fire capability exceeds our weapons by an order of magnitude. Its reliability under adverse conditions is unmatched. Its design philosophy reflects sophisticated understanding of automatic weapons engineering principles that we have not fully grasped. Most critically, the M2's existence suggests that American industrial capacity is vastly greater than intelligence estimates indicated. The precision manufacturing required to produce this weapon in quantity requires advanced machine tools, skilled workers, and quality control systems that we cannot rapidly replicate. If the M2 is representative of American weapons generally, we face an opponent whose material advantages are more significant than previously understood. The report was classified top secret and distributed to only the highest levels of Japanese military command. Its implications were profound. If American weapons technology exceeded Japanese capabilities by this margin, what hope did Japan have in a prolonged war against American industrial might? General Hideki Tojo, Japan's Prime Minister and War Minister, read Yamamoto's report with mounting anger. The notion that American weapons might be superior contradicted fundamental assumptions underpinning Japanese strategy. Tojo ordered additional testing to verify Yamamoto's conclusions, convinced that the engineer had somehow been deceived or had exaggerated American capabilities. In December 1942, a second team of weapons experts conducted independent testing of the captured M2S. Their conclusions matched Yamamoto's. The weapon was extraordinarily reliable, capable of sustained fire that exceeded anything in Japanese arsenals, and represented sophisticated engineering that Japan could not quickly replicate. Major Yoshiro Tanaka, who led the second evaluation team, added his own observations to the official record. "We tested the M2 under the most severe conditions we could devise," Tanaka wrote. "We fired it until barrels glowed red-hot, then immediately submerged the weapon in cold water, a thermal shock that would crack inferior barrel steel. The M2's chrome-lined barrel survived without damage. We fired Japanese ammunition through the weapon, ammunition manufactured to lower tolerances than American specifications. The M2 functioned reliably despite the inferior ammunition. We attempted to induce failures through deliberate abuse, inadequate lubrication, carbon buildup, damaged feed mechanisms. The weapon continued functioning. Only when we physically broke critical components, actions no weapon could survive, did the M2 cease operating. The conclusion is inescapable. American weapons engineering has achieved capabilities we have not matched. The psychological impact of these findings on Japanese weapons engineers was profound. Many had spent careers believing Japanese technical excellence was inherently superior to Western engineering. The M2 shattered that belief. Here was objective proof that American engineers had solved problems Japanese engineers had not recognized, using methods Japanese industry could not replicate without years of investment and development. Yamamoto personally supervised one final test in early 1943. He wanted to determine, definitively, the maximum round count the M2 could achieve before critical failure. Using all three captured weapons in rotation, his team conducted a marathon firing session that consumed over 100,000 rounds of captured American ammunition over a period of 6 days. The test protocol was brutal. Sustained fire in 500-round increments, barrel changes as specified in American manuals, minimal cleaning between firing sessions. The goal was to simulate the most intense combat conditions possible and determine when the M2 would fail catastrophically. At 75,000 rounds cumulative across the three weapons, minor parts began showing significant wear. The extractors needed replacement. Feed pawls showed edge wear. Firing pins exhibited mushrooming on their striking surfaces. But these were replaceable components, small parts that any competent armourer could change in minutes. The critical components, receivers, bolts, barrels, showed stress, but no imminent failure. At 100,000 rounds, Yamamoto called a halt. He had sufficient data. Extrapolating from observed wear rates and material degradation patterns, he calculated that the M2 could achieve approximately 1.2 million rounds of service life before the receiver itself would require replacement. Individual barrels would need changing every 3,000 to 5,000 rounds depending on firing intensity. Bolts would require replacement every 150,000 rounds. Feed mechanisms might need replacement, around 300,000 rounds. But the core weapon, the receiver that served as the foundation for all other components, could theoretically fire over 1,000,000 rounds before metal fatigue induced cracks that would mandate replacement. This durability was unprecedented in machine gun design and represented a service life 20 times longer than comparable Japanese weapons. Yamamoto's final report, submitted in March 1943, made recommendations that were never implemented. He suggested comprehensive redesign of Japanese heavy machine guns to incorporate principles observed in the M2. Chrome-lined barrels, heat-treated bolts, quick-change barrel capabilities, simplified feed mechanisms. He proposed establishing quality control standards matching American precision. He recommended investment in advanced metallurgy research to develop steel alloys matching American specifications. None of these recommendations were adopted. Japanese industry, already stretched thin, supporting multiple war fronts, lacked capacity for comprehensive weapons redesign. The materials science research Yamamoto proposed would require years to yield results. The quality control improvements demanded machine tools and inspection equipment Japan could not manufacture domestically and could no longer import from Western sources. But perhaps most critically, Japanese military leadership was unwilling to admit that American engineering had achieved superiority. To do so would undermine the ideological foundations of Japanese military culture, which held that Japanese spiritual superiority would overcome any material disadvantages. Acknowledging American technical excellence threatened that narrative. The captured M2 Browning machine guns remained at the Technical Research Institute through the remainder of the war, occasionally used for reference when Japanese engineers attempted to develop improved weapons, but the lessons they taught were never fully absorbed. Japanese weapons development continued along established paths, producing incremental improvements to existing designs rather than revolutionary advances, matching American capabilities. Captain Yamamoto continued his work throughout the war, analyzing captured American weapons as they became available. He studied the M1 Garand rifle and found it superior to Japanese rifles in every meaningful metric. He examined American aircraft machine guns and found them more reliable than Japanese equivalents. He analyzed American artillery shells and found their metallurgy and explosive formulations more sophisticated than Japanese munitions. Each analysis reached the same conclusion. American weapons engineering reflected industrial capabilities and technical sophistication that Japan could not match. The war of production, the contest of industrial might that would ultimately determine the Pacific War's outcome, was one Japan had already lost, though few in Japanese leadership would admit it. In his personal diary, Yamamoto recorded thoughts he could never include in official reports. "We began this war believing American soldiers were soft, their equipment inferior, their industry incapable of matching our determination. The M2 Browning has taught me we were wrong on all counts. This weapon reflects a society capable of precision manufacture at scale, engineering sophistication married to practical design, and quality control that ensures reliability across millions of units produced. If America can build millions of machine guns to this standard, what else can they build? How many ships? How many aircraft? How many tanks? We assumed American industrial capacity was a myth. The M2 proves it is reality. We are fighting an opponent whose material advantages we never properly understood." By 1944, American forces were systematically reconquering territory Japan had seized in 1941 to 42. Wherever American forces advanced, M2 Browning machine guns provided devastating supporting fire. Japanese soldiers learned to fear the distinctive sound of the .50 caliber weapon, its heavy pounding rhythm, announcing destruction that could penetrate cover and tear through defensive positions. Japanese after-action reports from Saipan, Iwo Jima, and Okinawa consistently noted the destructive effectiveness of American .50 caliber machine guns. Officers warned their troops that American heavy machine gun positions could not be approached directly, that flanking maneuvers were essential, that American firepower superiority was overwhelming. These tactical lessons were learned at horrific cost. Japanese infantry, charging American positions with courage that bordered on fanaticism, were cut down by M2 fire at ranges where their own weapons were ineffective. The sustained fire capability that Yamamoto had documented in Tokyo laboratories translated to battlefield dominance wherever American forces deployed the weapon. On Okinawa in April 1945, Marine Gunnery Sergeant Frank Morrison operated an erosion M2 Browning during the battle for Sugarloaf Hill. Over 3 days of continuous combat, Morrison's weapon fired an estimated 35,000 rounds, repelling multiple Japanese counterattacks. When relief forces finally reached his position, they found Morrison still at his gun, surrounded by spent brass casings and empty ammunition cans. The M2 was still operational, still capable of sustained fire, a monument to John Moses Browning's engineering genius created 27 years earlier. Morrison's weapon was not exceptional. Across the Pacific, thousands of M2 Browning machine guns were firing similar round counts, sustaining similar abuse, and functioning with the same reliability that had so impressed Japanese engineers examining the first captured examples in 1942. In August 1945, when atomic bombs devastated Hiroshima and Nagasaki, and the Soviet Union entered the war against Japan, the Imperial Japanese Army Technical Research Institute was evacuated. In the chaos of Japan's collapse, most research records were destroyed to prevent them from falling into Allied hands. Captain Yamamoto personally burned years of reports, technical drawings, and analysis documents in the Institute's courtyard, watching smoke rise from knowledge that would never serve Japanese military purposes. But Yamamoto saved one document, his comprehensive report on the M2 Browning. He hid it among personal papers, recognizing that future historians might find value in understanding how Japanese engineers had perceived American weapons technology. The report survived and was eventually discovered by American occupation forces in 1946, translated and filed in military archives where it remained largely forgotten for decades. The 3 captured M2 Browning machine guns were recovered by American forces during the occupation of Japan. Serial number 127856. Staff Sergeant Michael Donovan's weapon from Bataan was identified through its serial number and manufacturing markings. The weapon was cleaned, refurbished, and eventually placed in storage at an army depot, just another piece of surplus equipment in the vast American military inventory. Donovan himself survived the war, though barely. He endured the Bataan Death March, 3 years in Japanese prisoner of war camps, and repatriation in September 1945, weighing less than 100 pounds. He returned to civilian life in Milwaukee, worked as a machinist, married, raised 3 children, and spoke rarely about his war experiences. When he did discuss the war, he always mentioned the M2 Browning with something approaching reverence. "That gun saved my life, and the lives of every man in my unit more times than I can count," Donovan said in a 1982 interview with a local newspaper. "We poured fire downrange for days on end, and it never quit on us, not once. I've worked with machinery my entire adult life, and I've never seen anything built to those standards." John Browning created something that just refused to die. The M2 Browning remained in American military service long after World War II ended. It saw combat in Korea, where its reliability in brutal winter conditions impressed a new generation of soldiers. It fought in Vietnam, where its ability to function in tropical humidity and monsoon rains proved invaluable. It served in the Gulf War, in Iraq, in Afghanistan, and in every American military action of the late 20th and early 21st centuries. As of 2024, the M2 Browning remains in frontline service with U.S. forces and dozens of Allied militaries worldwide. Weapons manufactured in 1942 are still operational, still capable of delivering devastating firepower with the same reliability that impressed Japanese engineers 82 years earlier. No other weapon in military history can claim such longevity. The million-round durability that Japanese engineers found impossible to believe has been verified thousands of times over through decades of service. The M2 Browning is, by any measure, the most successful machine gun design ever created, a weapon that defined the standard for reliability and established benchmarks that modern weapons still struggle to match. John Moses Browning died in 1926, never knowing his creation would serve through a century of warfare, never understanding that his obsessive pursuit of perfection had produced something that would outlast empires, outlast the enemies it was designed to defeat, and outlast the assumptions of engineers who could not comprehend how an American weapon could be so much better than anything they had created. Captain Hideaki Yamamoto, who devoted months to analyzing the M2 and understanding its secrets, died in 1968, decades after the war he had served. In his final years, he occasionally spoke to engineering students about the lessons he had learned examining the American machine gun. Engineering is not about national pride or ideological superiority, Yamamoto would say. It is about solving problems through rigorous process, analysis, and practical testing. The Americans solved the problem of creating a truly reliable heavy machine gun. We Japanese engineers convinced ourselves the problem was unsolvable, so we never truly tried. That was our failure, not a failure of capability, but a failure of imagination. The M2 Browning stands today as a monument to what can be achieved when engineering excellence is pursued without compromise. It remains a testament to American industrial capability at its finest, a weapon that simply refused to fail, no matter how much abuse it endured. And somewhere in military archives, Captain Yamamoto's report remains preserved, a Japanese engineer's grudging admission that sometimes the enemy builds something better than you can. And the honest response is not denial, but understanding and respect. The American farm boy gunsmith had created perfection. The Japanese engineers who examined his work could only document that perfection and wonder at the industrial civilization capable of producing such weapons by the millions. The mathematics of warfare had indeed been rewritten not through ideology or determination, but through superior engineering executed with relentless precision. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.